So combining like terms. So the bottom line here is that you can actually simplify expressions even if you have variables involved. So most of what we've done so far with simplifying expressions has just been doing order of operations. So there's only numbers involved. But you can simplify an expression even if there's variables. You just won't be able to simplify it down to a single constant number. So you won't get it down to just one number, but you can still simplify things. So our steps for combining like terms, and these are terms that are alike. So when we think to our duck activity, all of the ducks were like in one family, they are one type of term. Then we had our terms that were our pens, or our term that was our pencils. There were different like families, different groupings. We're going to start by boxing in any terms with the same variable. So for example, an X. So if there's an X in the term, we'd say it's part of the X family. Now you would use a different shape for each family. So if there's more than one variable, for example, example 3 at the bottom has an X and a Y, you would just use a different shape for each, because you can't combine them if they're part of different families. So after you box in the terms with the variable, then you're going to circle any terms with only a constant in them, meaning it's just a number, no variables in the term. And then you get to put your families together. So example 1, I'm going to box in my terms that have my X. When I do this, so I would box in the 3X. When I box in the X here, I'm also going to box in that minus sign with it, and we're going to treat it as a negative sign. Subtraction and negatives, remember, they go hand in hand. And so when we're boxing in our terms, if there is an operation sign in front of it, like addition or subtraction, we're going to box it in as part of that term. I'm also going to highlight here because I like to color code things. I think it makes it a lot easier to kind of spot the different groupings or the different families here. Then I'm going to circle any of the terms that only have a constant. So that would be like my -7, my +5, and my -8. Notice how there's no operation signs kind of floating in between my shapes here. There's no plus signs or minus signs that are in between like my circles and my boxes. To distinguish these a little bit further, I'm also going to shade these in blue. Okay, so everything that's a constant, I not only circled it, but I also shaded it in blue, different color. So then we're going to put our families together. So we're going to make a little T-chart for this. So I have my everything that's part of my X family, and then everything that's part of my constant family. So for my X family, I would have my 3X, and I would have my -X. Then for my constant family, I would have my -7, I would have my +5, and I would have my -8. And we're basically going to combine these or add these up. So I have a +3, I subtract an X, or excuse me, I have a +3X, I subtract an X. If you wanted, you could put a little 1 coefficient there, so you know you're taking away 1 X, but 3X minus an X is going to give me 2 X's. Then on the right-hand side, -7 + 5 - 8, okay? So you could put these in a calculator. You will have a calculator for this unit, but we can do this without it. Simple enough integer operations. So if I have -7 + 5, that would give me -2. I subtract another 8, that would give me -10. So in simplest form, the expression would be 2x minus 10. I could simplify all of this mess here where I have like multiple x's, multiple numbers kind of being added or subtracted throughout, and group all the numbers together, group the variables together, and condense it down to this. Example 2, I'm going to do the same thing. I'm going to start by boxing in any of my terms that have, this time it's a y rather than an x, but I'm going to box in my terms with my variables. So that negative sign, again, goes with my term. It's negative 12y. And then I would have negative 4y. Again, I'm going to shade these in a different color. I like to color code everything. I think it makes it easier. And then my constants are just this 15, and that is a positive 15. If you want to put a little plus sign out in front of it, you can, if that helps you. This is a positive 10 and a negative 9, and then we just combine them all together. And that's what the little T chart helps you do, is just combine them. So this time it's my y family and my constant family. So in my y family, I would have negative 12y, and I would have negative 4y. In my constant family, I would have 15, a positive 10, and a negative 9. And again, when we're combining these, we're basically just adding them up. So I'm adding a negative 12y with a negative 4y. So if I have a negative 12 and I have a negative 4, together I have negative 16. And I'm going to keep that variable with it. So it's negative 16y. You can think of that variable being a different label, like ducks. 16 ducks versus just 16. They were represented differently with our ducks and our pens and pencils. All right, then I have, this is 15, it's positive 15, right? Plus 10 would give me 25, and then I subtract 9 from that 25, that would give me a positive 16. So I'm not just going to write the 16 here, it's a positive 16, so we would put a plus sign in front of it. And then this is my simplified form for my expression. Negative 16y plus 16. Again, we grouped all of the numbers together that were basically part of the same family to kind of condense things. If you notice example 3 here, example 3 is a little bit different in that it does have more than one type of variable. So there's actually 3 families we're going to be looking at here. I'm going to start with my x family. So I would box in my positive 4x. That's the only x term I have, right? I can circle my constants like I did in my other examples. So I just have 2 and positive 11. So here's my x term. I'm going to shade in my constants. And now there is something I've not kind of put any shape around here, and that is my negative 2y. So basically, if we have a different family, you just want to use a different color or a different shape to kind of distinguish it. So for this, I'm going to draw a triangle. And if you have a third color highlighter, you're welcome to shade this in a different color. Our notes in class, I just left it blank, like I just left it white. But if you want to color that in a different color, you can. So here's our 3 families we're going to have. We're going to have our X family. We're going to have our Y family. And I'm going to abbreviate here. But we're going to have our constant family as well. So you just have more columns in your tree here. So my X family, I just have the positive 4x, and that's it. My Y family, I have the negative 2y, and that's it. For my constant family, I have negative 2, and I have positive 11. And then we can combine these, add them up. I'm not adding anything to this positive 4x, right? So I basically just carry that down. And I don't need to write that plus sign out in front because if a number is positive, you don't need to put a plus sign in front of it. So that's part of like simplifying is getting rid of stuff you don't need. There's nothing to combine with the negative 2y, so just carry that down. And then if I have negative 2 plus 11, that would be a positive 9. So again, you have to put like your plus sign there or a positive sign out in front of the 9. You can't just have the 9 there without something connecting it because it is part of a different family. And this is actually as simplified as this expression is going to go. Again, with what we're doing, you're not substituting anything in for your variables right now. You're not simplifying this down to just one number that's a constant. All we're doing when we say simplifying these expressions is we're just combining the terms that are part of the same family so that we have like less messiness, basically. Now this last example is a little bit different in the fact that I have something that's in parentheses and then I have my negative 3 on the outside. So I'm going to go through a couple different steps here. Basically, before we can create our families, group our families together, just like with our ducks when we had 3 groups of x plus 3, we said we had to use the distributive property in order to figure out like what this actually would look like, okay? So we are going to distribute this, but before we even do that, I'm gonna start with our boxing and circling because it will help you keep your positives and negatives straight. So I'm gonna box in my term that has my x, which is the negative 9x, and I can shade that in. And then I have a constant that's on the outside, a constant in the parentheses, and a constant at the end. Now with all of this circling and boxing in, my parentheses kind of have gotten hidden behind my ink. So I'm just gonna redraw those parentheses so that like you can see them. So I have, again, 2 different terms within my parentheses. Now we have to distribute the negative 3 to each of these values inside. So we are going to, that means multiply negative 3 by each of these values, okay? So I have negative 3 times 10. So negative 3 times 10, remember your face over here? A negative times a positive is going to be a negative, so that would be negative 30. Then when we distribute that negative 3 to this negative 9x, take that negative 3, multiply it by the negative 9x. Now, you can multiply a constant times a variable family. You can multiply numbers in different families. You just can't add them. So if I'm multiplying the negative 3 times the negative 9x, I'm basically multiplying the number part and keeping the variable. So negative 3 times a negative 9, negative times a negative is a positive, would be a positive 27. Keep the x. So now I have distributed. So the negative 3 times the 10 was negative 30. The negative 3 times the negative 9x was the positive 27x. And then I can't forget about this plus 14 that was out to the side. That didn't get distributed, but I can't just get rid of it. Now, once I've distributed, now I can group my families together. You can't group your families before you distribute. So I'm going to box in my term with my variable, so my positive 27x. And circle my constants, so negative 30 and positive 14. And then I can group those together with my families. So I have my x family again, and I have my constant family. There is only one term in my x family, that is my positive 27x. In my constant family, I have negative 30, and I have positive 14. I combine these. Again, nothing to combine with the positive 27x, so I can just carry that down, and you can get rid of the positive sign in front of it. You don't really need that, right? And then negative 30 plus 14 would be a negative 16. So we basically write that as minus 16. So the bottom line here is we're grouping our families together and then adding them, combining them. If I have a number within, if I have numbers within parentheses, I always have to distribute before I can group my family. So you have to distribute first.